This lesson is about probability. Our objective is to be able to use geometric probability to find the probability of an event. Now, this is an introduction to probability, so let's talk about what probability is. First of all, probability is the chance that an event happens. So when we do it though mathematically, what we want to do is be able to analyze what the success possibility is. That goes in the numerator of our fraction, and on the bottom goes the total of what we're talking about. Now, when we're talking about geometric probability, the probability involving geometric figures, the success would be where it would fall inside of the area that we're talking about, and the total would be the total area we're talking about. So probability always will fall because it's success over total. You can't get more than the total, so the largest probability could be is 1 if we had the total amount was success, and we have total over total. And the lowest amount could be 0 if we have no success over the total amount. So using this circle as the total that we talk about here, what we need to do is analyze this circle and this triangle and this square. We're saying that the square has a side of 10 and the triangle has a base of 5. So let's start with the ones that we know. We can figure out what the area of the square is, and that's just 10 times 10, or 10 squared, which equals 100. Now this triangle, if it's got a base of 5, notice that the height of that triangle is going to be the length of the side of the square. So the base is going to be 5, the height is going to be 10, area of a triangle is 1/2 times the base, which is 5, times the height, which is 10. So if we multiply half of 50, we get 25. Right, now we've got to figure out the radius of the circle to be able to figure out the area of the circle. Since this is all based on area, we want to figure out the area of all of our figures. So if we're going to go with the radius of this circle, I'm going to draw it on the diagonal. Notice that if I were to continue that, I've got the whole diagonal is the diameter of the circle. So diameter, diagonal, the same in this case. So if we use the Pythagorean theorem, where we've got side here is 10, side here is 10, so we have 10 squared plus 10 squared is going to equal the diagonal squared. So now we're going to have 100 plus 100 is 200 equals the diagonal squared. And if I take the square root of both sides, the diagonal is going to be the square root of 200. Now we like to simplify square roots. In this case, I'm going to be relying on decimals later in the problem to do the problem, but I do want to do this one for a little bit, simplify this a little bit because I want the radius, not the diameter. So I'm going to take out of this, we've got the square root of 100 goes into it. So we've got the diameter equal to the square root of 100 times the square root of 2. 2 times 100 gives me that 200. So the diameter equals 10 square roots of 2. So my radius is going to equal half of that, or 5 square roots of 2. So the area of the circle, remember area of a circle is pi times the radius squared. The radius here is 5 square roots of 2. If I square that, I'm going to square the 5 and get 25. I'm going to square the square root of 2 and get a 2. So we have pi times 25 times 2. So that's going to give me 50 pi for the area of the circle. All right, so now we've got the area of each of our figures. We can figure out the geometric probability. Geometric probability is based on this success over total. So what we're going to do is look at each of these situations that are listed for us and see what success is, and then we're going to list it over the total, which in this case is going to be 50 pi, because the circle is 50 pi, and that's the area of my circle, and that's the largest geometric figure we've got here that we're using for this. Now, let's go ahead and do the triangle. Our area of our triangle is equal to 25. So in exact terms, this is going to be 1 over 2 pi for that. I'm going to go ahead and do that on a calculator and get the decimal here. So we'll see that it falls between 0 and 1. So on my calculator, I'm going to do 25 divided by, and then I need 50 pi. I'm going to put that in parentheses. So put my denominators in parentheses, and I get basically if I round it, I get 0.159 or 0.16 approximately. So this is about 0.16 for falling in. If something were to land somewhere in the circle, the probability, and it would land somewhere randomly in the circle, the probability of it landing in the triangle would be about 0.16. All right, now if we want the square but not the triangle, we need to take the square amount and subtract the triangle. So success would be the square, which is 100, subtract, because we not want it to not land in the triangle. The triangle is 25, and we're going to divide that by our total, which is 50 pi. So that will be 75 over 50 pi, which in essence is this one tripled, right? So if I take my, if I were to go ahead and do it over again, I could get, it'll end up being this one tripled. So if I go ahead and do my 75 divided by parentheses 50 pi, and see what I get. And I get about 0.47, 0.48. So about 0.48. If I round it to 2 decimal places. All right, now let's do the not square. Now this one again, if circle's my entire area, I'm going to put this over 50 pi. My entire area is 50 pi. And I'm going to subtract off the square because I want just these little areas here. And instead of trying to figure out what each of those are, it's better if it says not something to take the bigger figure and subtract the smaller so that I get what's not in that area. So that would be 50 pi minus the area of my square, which is 100. I can do that. I don't even need to simplify that because it can't. Remember, we want to go ahead and get this into a decimal form. Okay, make sure you don't, one error that people tend to do, because of the minus, this is like a grouping symbol. The fraction bar is a grouping symbol, so everything in the top goes together. Don't be reducing the 50 pi's because it's not a factor. Let's take a look at our calculator. Now let's go ahead and do parentheses. 50 pi minus 100, and divide that by my 50 pi in parentheses. Okay, and that gives me a probability of about 0.36. All right, so that's when we have geometric figures. Success would be the figure that it's saying probability of a triangle. That means triangle's the success. You put it over the total, then you get your probability, which will lie between 0 and 1. All right, let's look at spinners. It's another possibility. So let's say we've got these different possibilities. Just a reminder that a full circle is 360 degrees. So if we talk about this being 60, this is a straight line, and so I've got supplements. So another geometric review for you is that if I want this angle here, I take 180 minus the 60 and get 120 degrees. Same thing here, if I take 180 minus the 45, I get this angle to be 135. So you want to use your supplements to get that. So if I want the probability of lions, I'm going to do 120 divided by 360 because that's the number of degrees in a full circle. And if I reduce that down, I can reduce it down to 1/3. Okay, so that would be in fraction form, the probability, which you can list it as a fraction, but also as a decimal then, that's about 0.33 for my decimals, 0.3 repeating exactly. Right now for probability of a winged creature, well, lions and mice are not winged, so I want to take sparrows and bats, those have wings. So I'm going to take and add those two together to get success, so 60 degrees plus my 135. I'm going to divide that by 360, so it's going to be 195 over 360. So I'm going to take this fraction and make it into a decimal. So let's go with 195 divided by 360. And I get about 0.554 for that one. All right, now we want to do the probability of not bats. Now, what does that mean? Well, the things that are not bats are lions, sparrows, and mice. So you could just add up those if you want to, or we could say not bats would be the entire 360 and subtract off the 60 degrees, which are bats, and put that over 360. So I'm going to get 300 over 360. So now we're going to get the decimal of 300 over 360. And that's about 0.83. All right, so that's geometric probability with spinners. You just have to, it's based on circles, so 360 degrees. Let's do geometric probability with segments. Now for this one, I'm going to set up the segment. It says on a 20-mile straight road, so I'm going to list a 20-mile road here. So from here to here is 20 miles. It says that Joan has driven 12 miles. So Joan, I'm going to mark off here as 12 miles. Okay, and then it says that Nate has driven 7 miles. So this is Joan. We'll say that Nate just goes 7 miles. Okay, so we want the probability of Joan but not Nate. So that's between these two right here. Falls on Joan would be here in the 12, but Nate takes up 7 of it. So this right here, Joan but not Nate, would be 12 minus the 7 over the total, which is 20. That gives me 5 over 20, which is equal to 1/4, which is equal to 0.25 for my probability. Now, if we want the probability of neither, then notice that neither would be this part past Joan. That would be 8 out of the 20, which we could reduce down to 4 over 10, which is 0.4 for a probability. So probability is the chance that an event will occur, will happen. The probability, how we calculate it, is we put the success, whatever we're trying to find the probability of, that event, over the total, whatever the total area or segment or degrees are. And then we go ahead and calculate probability, which will always land between 0 and 1.